Okay, so the thing with um, designing experiments is that there is literally an infinite number of answers. There's not one answer. There's multiple answers. So it has to have the correct parts though, and it has to have them done correctly, right? That's the thing. There's outlines, there's different types of outlines, there's different ways to outline, there's different ways to label the outlines, there's different designs you can do. So there's literally an infinite number of answers. That doesn't mean every answer is right though. There are wrong answers, mainly because you forget something. Okay, so um, that's the thing with when you're designing an experiment, not forgetting something. That's the main issue. It's not necessarily something that's wrong. It's just you forgot to be more specific. You forgot to include this. You forgot to include that. You forgot to label that. That's mainly where the mistakes happen. Okay, so I'm going to show you one possible. Now, does it have to be exactly like yours? No, there's different ones. There's different ways to design an experiment that answers the question. Okay, the question that we want to answer is right here. Is there a difference in pecan yield using desalinated water? That's one of the biggest issues with California, especially right now. We don't have water. Water is just not available, and that's an issue, especially in our area, because this is where we grow. This is where things are grown. Most of the food that we eat comes from this area. Okay, so if that area does not have water, that's a problem. So one of the ways, there's been many ways they've kind of come up with ideas on how to fix it, is using what's called desalinated water. Taking water that's seawater, mainly seawater, right? Any water that has salt in it. Well, you have the Pacific Ocean not too far away, and that has more water than we could ever use, right? So why not just get that and ship it over here, desalinate it, and we can use it? Well, the problem with desalinating is even if you take out all the salt or take out the salt, you can do it as best you can, but it's still going to have more salt than regular groundwater. It's just going to have you can salinate it and salinate it and salinate it, but desalinate it and desalinate it and desalinate it, but it's still going to have more salt than the normal groundwater. Is that a problem? If it's not a problem, then sure, let's do it. Go to the Pacific Ocean. You have tons of water there. If not, if it doesn't work, then we got to go something else. So we have to design an experiment saying, is there a difference between pecan? They're doing pecans here. Pecan yield using desalinated water. Okay. So the first thing, they don't give you numbers. They don't say use 100, 200, 300, 1,000. They don't say any of that stuff. So you come up with a number, 100, 200, 300, 500, whatever you want. Okay, because they don't give you that number. So whatever the number is, for round purposes, let's use 100. So who or what are the experimental units? That's not the units. That's the treatments. Who is being, that is what's being done. Who is it being done on? The land, right? The land. That's what it is. The land. Okay. So 100 plots of land, let's say. 100 plots of land. Where did I say I get it from? I said that literally a couple minutes ago. Where do I get 100 from? Thin air. I just made it up. It could have been 200, could have been 300, could have been 400. If they don't give you the number, I'm just going to use a number. Okay? Most of the time they'll give you a number. Like the last one, here they gave you a number. 36, 12, 48. They tell you. Most of the time they'll tell you. Um, the one we did earlier, the one we did last time, we said 100 students because again, they didn't tell us. Most of the ones that come from your book, they'll tell you how many. They'll say we got this many. Okay? Okay, so we got 100 plots of land. Okay. One way I would do it is break them into two groups. Group one would be the treatment group. Treatment group is what they're introducing. What they're introducing is the desalinated water. Okay, so the treatment would be a group. So it would be around 50 plots that are getting desalinated water. Okay. The control group would be just the ones that get groundwater, what they do right now. They use groundwater. Okay, groundwater is the water we drink. It's just the water that comes from the ground after it's rained or whatever. Okay, so 50 plots. Control groundwater. Okay, make sure you label. I have number, I have treatment and control. Let me highlight them. And then I have who they are. Desalinated water, groundwater. Okay. Make sure you label each like I have there. I'm going to explain what happens in the desalinated water later, but just for right now, it's a picture. Okay. And then how am I going to know which one does better or which one does worse or if they're the same? How am I going to know that? Yield, yeah, yield. Yield of pecan. Yield of pecans. How many pecans am I able to grow based off of those things? Okay. I need to do randomization. Now I understand they're plots of land. So they're not people. So it's not like they know which one they're getting, but it's still important that I randomize. So the only place to randomize would be here and here. After you get your 100, you decide who are the 50 that are going to get the desalinated water, who are the 50 that are going to get the groundwater. Okay. All right. So that's my that is my outline. Okay. So now I have to do the write-up. I'm going to move this down here so I have a little bit more room. Okay. First one, randomization. Randomization has to explain two things. Where is it being done and how is it being done? Where is it being done and how is it being done? Most of the time, you will have to come up with your own process, your own system, your own rules. Okay. So where is it being done? Well, it's being done where it says RA in deciding who is the control group and who is the treatment group. Okay. So we say randomization is being done to split 100 plots of land into two groups. Desalinated water and groundwater. Okay. Okay. Now I got to explain how I do it. Well, that's up to me, but I just have to explain it. Label each plot 1 to 50. You can put all 50. You can put 50 pieces of paper in a hat. Pick the first, or sorry, not 1 to 50, 1 to 100. First 50 are going to get the desalinated water. Second 50 are going to get the groundwater. That's one way to do it. You can use your calculator. You can use your the random number table. Okay, any of those methods work. You just have to explain that as best you can. Okay, so you just want to explain that. So if you use, so I'll say, since I don't think I've done the random number chart in a while, I'll use that one. So using random number table, I will select two digits at a time. The first 50 selected will be treatment group. And next 50 will be groundwater group or control group. Okay. On tests, more than likely, they'll have you use a table. They'll give you a table or they'll say use a table. That's most time they use on tests. That's why I try to avoid that one when I'm doing a write-up, because it's easy just to say, oh, use the calculator to do it. But on test, most of the time they won't have you use calculator. They'll give you a table, or they'll say use this table here. Use this table starting at line 110. So you got to kind of explain your process. Okay. Okay, so that's randomization. Next one is replication. Replication. Okay, what do we explain for replication? What is replication? In replication, what do we have to address? Yes, so numbers, yeah. So we would say we have two different plots of land, or groups. It's probably a bad wording. Two different plots of land. They're not different plots. They're just what's being done to them is different. So we have two different groups of land plots. There you go. Two different groups of, would you say two different groups of land plots being used 50 plots will use desalinated water for growth. "50 plots will use groundwater for growth." So this is where I explain, what does desalinated water mean? Well, this is where I'm going to, that's the water I'm going to use to feed the plants, or to feed the trees, the pecan trees. Okay. All right. Last thing, control. Last thing, control. First thing you have to do is determine who is the control group. Okay, so control group is, or R, I should say, control group is 50 plots using groundwater. Okay. And then you have to determine, or not determine, explain how are you going to know which one is growing more, growing less. So we will compare yield of crops. Okay. Always. How are you going to know which one's better? You have two numbers. How are you going to know which one's better, which one's worse? Right? That's what you have to do. Okay. Okay, so there is one more on here, but I think it's better use of time if you just start on your assignment because that will be a little bit better. I have this one in here. You could use it. You know, it's a good way to study an extra problem, test type problem. Okay, but we're not going to do it in class. Let's see. Cold water. Let's see. Cold water washing is the best for keeping shirts the original color. The experiment setup. Shirts are washed 20 times. There is a choice of hot water, warm water, and cold water. Yeah, so whatever the question is, the question says cold, it's not really a question, but it says cold water, right? So that's going to be the treatment. So warm water and hot water. So there would be three groups. Oh, yeah. Yeah, you'll have some on your assignment here. Okay. So the treatment A is cold water, because that's what the question is referring to. This group here would be warm water, and this group here would be cold water. And then there's 48 total, so it would be 16, 16, and 16.
How do you know if there's a, like, for more than two, how do you know if there's a control? Or, because we know there would be one treatment.
So why did I do three groups for this one? Why do you think I did three groups for this one? No. Because it says right there. It says there's three choices of water. So yeah, this one would be no control. I would just compare all three. So if you want to say control, I would say the bottom two are control. But it's technically no control group. So I would just compare. So I would explain it's a comparison test to see which one best keeps the original color. Okay, so yeah, you could say there's two control groups. I'd accept that. Or you can say there's no control groups. I'm just comparing which one. I'm comparing all three. Right. Right. Mm-hmm.
So shirts are divided into like two things, like less expensive and more expensive. Does it change the question in any way?
Yes, it will. Yeah.
So 6 to equal.
So yeah, so 48. That's a great point. There's 48 total, so we know there's going to be 16, 16, and 16. So my randomization. So I'm going to have to randomize to go here, right? Random, random, random. Let's see, 48 shirts. I have to design a system so that not all of these shirts end up in one group. Because if I don't explain, I'm going to have to design a randomization system so that all of these guys don't go in one group, right? That would not be good if I had 12 here from here and then the other 4 over here from, because more expensive shirts mean they're made better, so they're less likely to lose their color. Okay, so the 36 from a less expensive, I'm going to sprinkle here, but I'm also going to sprinkle there. So my randomization, I'm going to have two systems for randomization. Randomization of the 36 and randomization of the 12. So you're going to have to explain your two systems, because you can't put all 36 together with these guys here and do randomization once, because then, like I said, these 12, it could become unbalanced. Each group, I want to have 12 from Old Navy, and I want to have 4 from J. Crew.
The other way around. You'd have 12 from Old Navy and.
That's what I said, yeah.
Okay.
That's exactly what, yeah. 12 from Old Navy and 4 from J. Crew. 12 from Old Navy, 4 from J. Crew. So you have to make sure, so you need two systems. You need one for those guys, and then you need one from the 4s. So you would have to, you'd have two systems for randomization. So in your randomization, this randomization here, the one I just did, I only had one system. I just explained. Labeled each from 1 to 100 and then split them into 2 groups. This guy, oops, not that guy. I would have to have two systems. That's, again, that's a whole. So if you just talk about, if you put them all together and say 48 total, one system, label them 1 to 48. Pick the first 16, pick the second 16, whatever your system is. That's a hole in your system, because one group could have more of variety. You want to make all 3 groups the same, as similar as possible. Okay. So like I said, that's the biggest thing I see, is people forgetting things, not realizing, oh, I just put them all together. No, because more expensive shirts are better made. So that's why they're more expensive. Better material, better way they were created, better stitching. So they're going to keep their color longer versus the shirts that are less expensive. Okay. Okay, so I'm going to give you some time to work.
Wait, so for that